Hello, for our continuation. For our midterm or week module 3, our topic is about RC Series AC Circuits. So, manaman to sa tong RL, so proceed to sa RC. When an AC voltage is applied across a series RC circuit, it draws a current that is leading with the AC voltage with an acute angle theta. So makita na to dere sa atong figure, natay voltage drop in the resistor or the ER, and now we have our voltage drop sa atong capacitor. So ang unit ani will be volt kaning duha. So makita po nato natay angle, acute angle theta. So kabalo na ta for our formula sa to ang I for the current if given ang voltage og impedance. We have E divided by Z or the impedance. And formula for our impedance, Z is equal to R squared plus XC squared. And our formula also in solving the voltage drop in a resistor, we have I multiply sa tuang resistor. And for our capacitor, we have I multiply sa tuang XC. So same. So given na ni sa tuang last topic, using complex number notation, we have here Z is equal to R minus J XC or I ni sa tong calcu, and S is equal to P minus JQ or our S is equal to E and the current conjugate. Kaning asterisk dere. So kaning current conjugate is ang iyahang opposite or iyahang example. If na negative, so therefore ma-positive ang atuang current. So in our example, so proceed ta for our example for RC series. So a series circuit consists of a 66.2 microfarad capacitor and a variable resistor. For what value of resistance will the power taken be 172.8 watts if the impressed 60 Hz EMF is 120 volts. So first, take note sa atong given sa atong problem para mas madali. We have our E, which is 120 volts, and our capacitor, which is 66.2 microfarad. Our F is 60 Hz, and our P is 172.8 watts. So makita na to. After na to masulat na tong given, we need to draw our figure. So since series circuit lang ni siya, so naay given nga R, which is kaning variable resistor or capacitance connected sa atong source nga 120 volts. Since naghatag man siya capacitor, so we need to solve the XC. So XC is equal to W over multiply sa tong capacitor. So we have here, substitute 1 over 377, makuha siya sa 2 pi, sa tong 2 pi F 60 Hz. Multiply to 66.2 microfarad, which is negative 6. Where capacitance will be, nabutang na ko ang parentheses diri sa ubos. So dapat na siya i-close. So we have 40.2 0.068 ohms. So we need to solve. So remember our formula for our P. So sa tong power we have here I squared R. Since nanatay given nga XC, so we need to use for our I is equal to E divided by C. Where ang atong C kay C squared is equal to R squared plus XC squared. So combine na to from our formula there is I squared. So we have E squared. So mao ni ang ato ang na-come up nga formula. So take note ani nga formula. If maghatag og same value sa atong next problem. So we have substitute. So para mas madali ta, we can solve by using shift solve sa atong calculator. Example, if namo sa board exam, so we need to 172 atong watts, 172.8 watts. So alpha kaning solve dere with na equals, so naman tay value tanan, we have 120 squared. So ang atong unknown R, so pwede ta mo use og alpha x divided by sa atong R squared, so alpha x squared plus 40 ohms nga for XC capacitance squared. So mugamit lang mo ani if ang ato ang equation is very taas na kayo, then lisod na kayo i-simplify. So I suggest pwede mo mugamit og shift solve nga technique. So mo ni siya shift solve. So solving for, so nalimta na to dire mo syntax error. So we have here so solving for our x, so shift solve. So wala na siya, example 0. So our answer will be 30 ohms. So automatic na siya. So therefore ang ato ang resistance, atong resistor na unknown is 30 ohms. So required lang mo mogamit og shift solve if taas na kayo ang process sa pag-solve. So mo recommend ko na mo practice mo og shift solve nga technique. So proceed ta for our second example. So calculate the capacitance of a condenser to be connected in series with a 100 volts 80 watts lamp to enable it to be used on a 200 volts 50 hertz supply. So take note ta nga gahatag siyag lamp. So therefore ang ato ang voltage drop sa tong resistor will be 100 volts. So first we need to write our given. So natay given nga E total niya which is 200 volts. Our ER for the lamp is 100 volts and our power is 80 watts. So first, since naana ta, we need to solve the resistor. So first, so formula, we have R, so E squared 100 squared divided by the power 80 watts. So our resistor will be 125 ohms. Kita na to dire, we have 125 ohms. Since na natay resistor, so we need to solve for our current. Solving for current, kani power ni dire. So I is equal to P over the voltage drop in our resistor. So we have 80 watts divided by 100 volts. Our current will be 0.8 amperes. So, before ta makasolve og XC, we need to solve for the impedance. So, the way man para masolve lang ang XC, so dapat na impedance. Since na naman tay voltage niya, then na naputay current, so pwede na nato masolve ang impedance. So, 200 divided by the current, which is 0.8 atong gisolve. Our impedance will be 250 ohms. So, nanatay impedance nga given. So, kani nga formula, XC is equal to square root of Z squared minus R squared. So, substitute since given tanan. So, square root of 250 squared minus 125 atong resistor. So, the answer will be 216.506 ohms. Since ipangita sa atong problem is capacitance, so we know already the formula for our capacitance, 1 over 2 pi f XC. Substitute 1 over 2 pi ang atong frequency, which is 50 Hz. Then atong dissolve nga XC, which is 216.506 ohms. Our capacitance will be, so we need to convert sa microfarad. So 14.7 microfarad. So that is our final answer. So I suggest you memorize our formula or i-take note ninyo sa inyohang notebook ang formula, tanan formula, kay magbalik-balik rami na siya. So proceed ta sa atong LC series. So an LC circuit is also called a resonant circuit, tank circuit, or tune circuit. So, an LC circuit pod is an electric circuit consisting of an inductor. So, represented by the letter L. So, ang LDI sa atong LC is stand for inductor. When an AC voltage is applied across a series LC circuit, it draws a current that is either lagging or leading with the AC voltage with an angle of 90 degrees. So, in LCDI, so, depende siya if hatag siya sa problem if lagging or leading ang ato ang current. So, take note ato. So, same sa atong figure na given nga XL, reactance, and XC. So, we have same ragyapon where atong I is the formula. Take note ani. I is equal to E divided by the impedance or Z. Where ang atong Z, ang formula sa atong Z or impedance is equal to absolute value of XL minus XC. So we have also for our voltage drop in inductor. So same ra sa taas. So, I multiply sa XL. And for voltage drop in capacitor, we have I multiply sa XC. So, naghatag siya note sa LC series circuit. Diba? Ngayon siya na either lagging or leading. So, unsaon na to paghibalo? If lagging ba siya or leading? If wala naghatag sa problem, so pwede na to siya mahibalan by if ang XL is greater sa XC. So, therefore, ang circuit is lagging pH. If LC nato is less than sa ato ang XC, the circuit has a leading pH. So, Take note sa ato ang note dira para unsaon pagpahibalo if lagging or leading power factor. So first, proceed sa atong example number 1. A 5 microfarad capacitor is connected in series with a variable inductor to a 20 volt 796 cycle source. For what value of inductance will the current be 2 amperes lagging? So diba naghatag na siya sa problem nga lagging ang ato ang current. So first we need to write our given. So our voltage is 20 volts and our current is 2 amperes. Our F frequency is 796 cycle source and our capacitor or C is 5 microfarad. So first, we need to solve for our impedance kay naa man tay voltage o current gihatag. So 20 volts divide 2 amperes is 10 ohms. So ato ang impedance is 10 ohms. So since ang note nato katong sa taas PF is lagging, therefore XL is greater than XC. So dapat ang atong ma-solve ron, dapat ang XL is greater than XC. So solve for XC since namatay capacitor nga given, so formula na siya, constant formula. We have 1 2 pi F na to is 796 multiply sa 5 microfarad. So our answer will be 39.98 or approximately 240 ohms. Since natay formula for our impedance na natay XC, so we need to solve for XL. So substitute 10 is equal to XL minus 40. So simplify natin na XL. So we have 10. So transpose na to ang 40. So negative. Since moagig equal sign, so mahimo na siyang positive. Therefore, ang atong XL is 50 ohms. So pwede nato ma-solve ang ato ang value for inductance. So formula for our value of inductance, we have here our formula. XL divided by 2 pi F. Itong XL is 50 ohms divided by 2 pi F nga 796 cycle source. So ang answer will be 9.997 or approximately to 10 milli Henry. So if very easy lang siya, no, if memorize na to ang ato ang mga formula. So proceed for our second example. We have a series circuit consisting of a 0.0795 Henry inductor and a 177 microfarad capacitor is connected to a 120 volts variable frequency source. At what frequency will the current be 4 ampere leading? So naghatag na pud siya sa problem nga atong current is leading. So first we need to write our given. We have E, our voltage is 120 volts. Our current is 4 ampere. And naa siya'y gahatag siya capacitor 177 microfarad. And our inductance which is 0.0795 Henry. So ang unknown nato will be the frequency. So balik, solve for our impedance. Same process, 120 divide 4 amperes. So our impedance will be 30 ohms. Since nag-ingon siya leading ang atong current, therefore ang XC/I is greater sa ato ang XL. So we have here, so natay 30 ohms. Then so given man nato ang capacitor o ang inductor, so pwede na nato ma-solve ang ato ang frequency. So simplify for the formula of XC, 1 over 2 pi FC minus sa XL is 2 pi FL. Since taas ang process, so giingon ako ganina, pwede na to ma-apply ang shift solve technique. So para mas madali. So we have, try na to, 30 ohms. Alpha, solve. 1 over 2 pi 177 ang atong capacitor, negative 6, and our alpha, which is X na to, or the frequency, minus 2 pi inductor na 0.0795, and alpha, our unknown, F. So therefore, pwede na nato mag-solve ang ato ang frequency. So advisable lang ha, mo gamit ta sa shift solve if dili mo confident mo simplify kay very long na nya, gamay rang oras. So pwede na to magamit ang shift solve technique since calculus man tong gamiton sa board exam. So we have shift solve. Tang na to if x is 0. So our answer will be 21.95 or approximately to 22 Hertz. So, diba, mas dali siya if mag-shift solve technique ta. So, sabtan ra ha, very easy lang ang atong mga example. So, proceed ta. So, it is a combination kaning RLC Series AC Circuits. So, when an AC voltage is applied across a series RLC circuit, it draws a current that is either lagging or leading or in phase with the AC voltage wave. So, in series, so natay given dire, voltage drop sa tong resistor, ER, and voltage drop sa tong inductor, and voltage drop sa tuang capacitor. So series ra na siya tanan na. So then ato ang voltage, ato ang source, then naay current na gadagan. So formula for current, so we have here I is equal to E divided by Z. Where ang formula, so take note ta, for RLC, ang formula for impedance is equal to square root R squared plus XL minus XC squared. So take note ha, aning formula very important ne. So formula for PUD, so same ra if voltage variable, we have ER squared plus EL minus EC squared. Where ang atong ER, so pareha ra, IR, EL, I, XL, voltage drop capacitor is equal to IXC. So in RLC series, naghatag pud siya, nag-take note siya dire. Kani siya ha, ang atong power factor very gamit ni siya. If ang XL is greater than XC, so laging PF. So ang nadungag ra ni if ang XL na to og XC is equal, therefore ang power factor is unity. So take note ana ha, if equals ra ang LC og XC, so unity ang ato ang power factor. So same, so kabalo nata ani na formula, balik-balik na ni. So you need to memorize this. So using complex number notation, we have here, So nadungag ra. So Z is equal to R plus JXL minus JXC. Same. Then current conjugate. So if positive for a lagging PF, inductive load, negative atong Q for a leading PF. So ang formula na to ani guys, balik-balik ra siya. So I suggest you write down all the formula para mas ma-memorize nato. So first example na to for RLC combination. So a series RLC circuit contains R 25 ohms, L is 0.08 Henry, and a capacitor C. The circuit is connected across a 200 volt 50 Hz supply. If the current drawn is 4 ampere leading, solve the value of C. So ang unknown na to is the capacitor. So first, we need to write our given. Our E is 200 volts and our I is 4 ampere. Our R is 25 ohm and our L is 0.08 and our F is 50 Hertz. So, take note tadaan sa ato ang mga given. So, solve for our total impedance. So, we have 200 divided by 4 amperes. So, ang atong impedance is 50 ohms. Here, 50 ohms. So, since na given nga L, inductor, so, pwede na ito makasolve og XL. So, 2 pi F50. L na to is 0.08. Our XL will be 25.13 or 8 pi ohm. So, mas gamito na to ning 8 pi kay mas dili siya para mas makapi na to ang tanan value. So, therefore, for a leading power factor, so guys, got diba sa atong current leading. So therefore, if leading power factor siya, ang atong XC is greater than XL. So expected na nga ang atong XC mas dako sa aning XL nga 8 pi ohm. So formula kani C squared. Take note aning formula. C squared is equal to R squared plus XC minus XL squared. Since na natay given sa tuang impedance, so 50 squared R 25 squared plus XC minus 8 pi squared. So our answer for our XC is 68.43 ohms. So solving for the value of C or the capacitor C, 1 over 2 pi F XC. So 1 over 2 pi, substitute 2 pi, we have 50 Hertz atong frequency, multiply sa atong capacitor nga 68.43. So the value of C or the capacitor C is 46.51 microfarad. So our final answer will be 46.51 microfarad. And for our last example for this module, so a series RLC circuit has a current which lags the applied voltage by 30 degrees. The inductor voltage is 10 volts and the capacitor voltage is 5 volts. If the resistance R is 20 ohms and the value is 100 rad per seconds, find the value of L. So first, we need to write our given. So given sa ta. So natay given nga R which is 20 ohms. And our inductor voltage or EL is 10 volts and capacitor voltage EC is 5 volts. Then naghatag po siya angle na 30 degrees. So ang unknown is L, ang value sa tuang L. So we need to use our triangle. So kabalo naman taan since naghatag og angle nga 30 degrees. So tangent theta natay angle dire. So angle theta is equal to, so ang tangent, di ba unsa man to? So katowa, so opposite is EL minus EC over towa adjacent, which is the voltage drop of resistor. Since given, solving for ER, so we have atong calcu 10 minus 5 divided by tangent of 30 degrees. Our voltage drop is 8.66 volts. Since naa naman tayo ER, then na naman tayo resistance given sa problem, we can solve for the current. So current is equal to ER over R. So 8.66 divide 20 ohms. Our current for our RLC circuit is 0.433 amperes. So solving for XL, since naanatay EL na to og atong current, so we have our EL of voltage, inductor voltage is 10. Our current is 0.433. So XL will be 23.09 or 23.1 ohms. So solving for value of L, so kabalo na tanan na formula. So 23 XL divided by W, 23.1 divided by 1000 rad, 1000 rad per seconds. So W, di ba, equal siya sa 2 pi F. Since naghatag nag W sa problem, so diretso na. So our value of L will be 0.0231 Henry or 23.1 milli Henry. So very easy, no? So I suggest you need to memorize the formula. So take note of every formula para ma-familiarize nato. So dali ra nato mahinumduman since gamit kanyo sa atuang board exam. So I hope na ay nasabtan for today's for our week class. So if na ay pangutana, pwede ra mo comment or personally ask ni ma'am. So that's all and thank you.